Today we are going to see the second part of the state space form. We need to find the so-called output equations, and we need to find out the C and the D matrices. So that's the topic of today's lecture, is find the C and the D matrices. Now, in order to do this, I am going to remind you about this example that we were working on last time, and maybe make some comments about it. So we have this situation here. We have this simple suspension system that you see here, and we have drawn the bone graft model on top of this, on top of the system in red here. And in here you have the process that we went about using to generate it. So in case that we need to do this, we redo, just to remind you, we laid out first the one junctions for the distinct velocities, then we attach the elements that move at those velocities, which are this and that and this and this and that. And then we created the zero junction to represent the difference in velocities. So between this and this created that one, between this and this created this one, and then finally we attached the elements that experience the difference in those velocities there. Okay, so let's see how we're going to do now the output equations. In this case, we have to identify some output equations, something that we want to monitor in our system. And so the C and the D matrix have to do with the outputs. So let's just figure it out for ourselves, which some of the outputs here, and perhaps I would just do, like, for example, if I want E10 and here's an output, so I'm just going to write the equations for that. So E10 as the output, and I could find E10 just like I found the equations, the differential equations. It turns out that E10 is very easy because it's 1 over C sub 10 and Q sub 10. This is the equation of this output. And there could be other equations for the other outputs that might be a little bit more involved than this, but maybe if we do, like, for example, and let's see, we could try an E7, just to E sub 7 is the force acting on this mass. This E sub 7 is E5 minus E sub 8, right? 5 minus E sub 8, and then E5 is E3, and E3 is E4, so this is E sub 4, and then E sub 8 is the one on top here, which is E9, and E9 is E10 plus E11. See, you could derive this equation like that. And so so in this case you will have E sub 7 is equal to E sub 4, which is this 1 over C sub 4 Q sub 4, and then minus, in this case, E sub 10 is 1 over C sub 10 Q sub 10, and then minus R11 times F11. Now, turns out that F11 is the only one that we need to expand in here, that we don't know very well. So F11 is going to be F9, see? But F9 is going to be F5 minus F sub 8. But in here F sub 5 is f3, and this is f3 is equal to f sub 4. Yeah, so this is no, f sub 5 is f1 minus f3. This is f sub 1 minus f sub 3. The f sub 1, which is f2, minus f sub 3. Yeah, this is SF5. This is SF1 minus what's f sub 3 is in this case equal to f sub 4, but this is where do we have this in here? It's not. Hopefully we don't have a mistake, so let's go back. F11 is F9, right? F9 is F8 minus F sub 12. Okay. Yeah, see, I somehow I messed up the numbers in here. So why don't we just erase this for a moment? I think we made a mistake. So F8 minus F12 is what it is. See what it is? It's F9, right? It's F8 minus F12. That was my problem here. This is F sub 8 minus F sub 12. And then F sub 8 is F sub 7. And then F sub 12 is F14. There we go. I'm sorry, we had a little mess up in there. This F7 is the 1 over I sub 7 P sub 7, and this is minus 1 over I14 P14. And so if we substitute that in the equation down here, we will have the whole equation for the output that we're looking for, this E sub 7. Huh? So let's do that. E sub 7 then is equal to 1 over C sub 4 Q sub 4 minus 1 over C sub 10 Q sub 10, and then minus R11 times this, so it would be over I sub 7 P sub 7, and this other one would be minus times minus is plus R11 divided by I14 times P14. These two equations that you have in here, I'm going to encircle them. This one right there and this other one in here, those are the two output equations that we are after, and those are the ones that we need to put into matrix form as well, just like we did the ones below here. We put the derivatives in here, the states vector in here, the outputs over here, and we fit these derivatives. In this case we have two output equations. We are going to have only two rows, where on one row is the output is E10 and the other one is E sub 7. So I am going to write it down like this. Let's just make it in here. This is E sub 10, and then this is E sub 7, and now we are going to have the matrices here that we need, like that. We have two rows. This is going to be the same state vector, like this, and then plus there's going to be another matrix like this, and it's going to have the vector of the inputs in here. So I think I'll be consistent with the same order of these state variables and the same order of the inputs. So I am going to write it down in here. This would be P14, and then you have a Q10 in here, and then you have P sub 7 in here, and you have Q sub 4 over here. And the sources, we had SC13, and then we had this other one, which would be SC6, and then we have this SF1. Okay, very good. So now we have to concentrate on the equations to write them down. See over here, 1 over C sub 10 Q sub 10, that's all it is. So this is going to be 0 here. Q10 is with 1 over C sub 10, and the other two are going to be zeros. See? And it has all these three also zeros, because you need to reproduce this equation that I'm saying, the output equation, like this, by multiplying this row of this matrix times this. So if you do that, it reproduces that equation, because we are doing it from the equation. Now here, in here we need, here E7 is, it has terms in all four of them. Like the first one is P14 is R11 over I sub 4. So E sub 7, so this is R11 over I sub 14. I think it's that's what it is, right on the, yeah, here on the right hand side. Then the term on Q10 is minus 1 over C10, minus 1 over C sub 10, and then you have the other term is about P sub 7, right here is this one, minus R11 over I7. So minus R11 over I7, and then you have Q sub 4, which is this one, 1 over C sub 4. 1 over C sub 4, like that. And then does it have any sources here? No. So this is other 3 zeros here. But the states vector and the input vector need to stay like this. Need to have all the rows and all the columns that it needs to have, otherwise we'll be making a mistake. So this matrix here is called the C matrix, and this matrix over here is called the D matrix. So we saw the format up here. This format that you see here is this format is this, no? And then you have the x dots equal ax plus bu. But this one here we can also write in the same way. This has this form: y is equal to the matrix C times the vector x of the state variables plus the matrix D times the vector of inputs U. So in conclusion, both of these are called state space form. State space form, you will say, of the system equations, because I say system equations because we have differential equations, but also these algebraic equations that are the outputs. So the state space form is always, and this I want you to keep in mind, is always x dot, the derivatives, multiplied by the matrix like this, times the input vector like this, plus the matrix B times the input vector U, and then on to complete, Y is like this. In fact, in Simulink you are going to see a block that has exactly this format that I am writing. It's because in that block is contained the entire system. So this form that you see here, this one right here, is called state space form, and we have derived now the A, B, C, and the D matrices. That is how we have done it by hand in this case. Just to remind you, in the case of the A and B matrices, we found expressions for the derivatives first. We derived all those, and each one of the four equations that we derived is one row of these matrices. See, we found an expression for this derivative, and then we wrote it into matrix form. Expression of this derivative on the matrix form in a row matrix. So we multiply this row by this column and should reproduce equation number 3. You multiply this row by this column and you add this, should reproduce equation number 4. So that's how this works. And then you will have this form for the A and B matrix, where these are the derivatives, the A matrix, the state space vector, and then you have the B matrix times the vector of the inputs. But on this one in here you have the outputs. This is the C matrix, this output matrix, and these are the state variable vectors. So again, by the same token, if we multiply this by this and this by this, should reproduce equation number 1 for output E sub 10. And if we multiply this by this and this by this, should reproduce the second equation for output E sub 7, which is this equation. So this way, what we can conclude is that this set of this representation in here and of the differential equations plus this set over here of the output equations is what we call state space form. So we can address any questions about that now, but in essence it boils down to this notation, and that notation is going to be very well done in the very well represented in the Simulink block diagram representation. Okay, so why don't we just stop now, and then we'll do that in a separate